Hey everybody, this is a supplemental video for 1.1.4. This is absolute value inequalities. And in the past, it's been just for our honors kids, but no longer is that the case. We've changed your curriculum, and now everybody's doing absolute value inequalities. So real quick, it's not really a great way to call them rules, but we call them rules on occasion. It's more of a trick. If you see absolute values with the greater than symbol, we think about those as or problems. So you misspell greater as great or. And for our less than or equal to problems, we think about them as and problems. So we misspell less than as a trick to help us remember that. I'll show you what I mean as far as the difference between or and, but these are the tricks you're going to see me use today to show off how to solve these inequalities. All right, getting right into it. Example 1, that is a greater than problem. So this is going to end up being an or problem. Now, or problems, when we solve them, you're going to end up with a solution that looks something like an answer going to the left and an answer going to the right. So two different parts. Over here, for number 2 is a less than problem, so that's an and problem, and those solutions are going to look something like two solutions coming together in the middle where they overlap. So you could see just visually what the difference in the two solution sets are, and now I'll show you how the numbers make those two things happen. All right, so we're again like inequalities of without absolute value. We treated them just like they were equations, so we're going to do the same thing here. Absolute value is isolated, so I could go ahead and split into my two scenarios. Again, I'm keeping in mind that it's a great or problem. So this is x minus 20 is greater than 5, or x minus 20 is, now switch your sign and then switch your sign. So that means less than negative 5. So notice that I've got greater than positive 5 and less than negative 5. So I'm going to the left and I'm going to the right. Add 20 to both sides, add 20 to both sides. X is greater than 25. Or add 20 to both sides, add 20 to both sides. X is less than 15. So I go to my solution picture so I could show all of the solutions to this inequality. I'll put 15 and I'll put 25, making sure that they're in the right order from smallest to largest. This is a greater, not greater than or equal to, so we're talking about open circles. And again, I'm going to shade x is greater than 25, that's bigger, that's this way, or x is less than 15, that's going to be to the left. So you can see how they're disconnected. And again, if you think about it, no number can be smaller than 15 and bigger than 25 at the same time. So it's got to be an or problem. So either they're smaller than 15 or they're bigger than 25. And you could see the two scenarios when we changed the signs, how that made sure that happened. All right, we're going to pick a less than problem that's a little bit more complicated. So let's go with number 3 here, where we have to do an extra step. Keeping in mind, actually, let's do 5. Keeping in mind this idea of less than, and we're now going to have an overlapping solution. So, again, we're thinking it's an and problem because of the less than. And again, in our head, we're thinking that it's going to be an overlapping solution where we're going to have things kind of coming together in the middle as opposed to going in opposite directions. And I'll show you how that happens with numbers. But first, before we could break out into scenarios, we've got to isolate our absolute value. Subtract 15 from both sides. And I've got negative 3 times the absolute value is still less than negative 30. And in order to isolate my absolute value bars, I need to divide by negative 3. Now, interesting enough about this problem is it's going to change the sign because I'm dividing by negative 3. And so that's going to end up being absolute value of x minus 5 is now greater than positive 10. And so actually it's just turned into an or problem. And so we're going to have the two different pieces like we had before. So we'll finish this with this idea that our solution is going to look something like that. So x minus 5 is greater than 10, or x minus 5 is less than negative 10. Don't forget to switch the signs. Add 5, add 5, add 5, add 5. X is greater than 15, or x is less than negative 5. Graphing my solution set, I put negative 5 to the left, 15 to the right, open circle, x is bigger than 15, or x is smaller than negative 5. All right, so now we've got two ors under our belts. Now let's go get an and scenario here, and I'll just scoot back up to, let's try number 3. I should have done that in the first place. All right, add 7 in order to isolate the variable, and I get, the absolute value. Absolute value is less than 17. Again, it's a less than, so we're thinking an and problem. And again, that solution is going to meet in the middle. All right, so now breaking our two scenarios, 2x plus 3 is less than 17. That stayed the same. Here we go. And watch what I do here. Negative 17 is less than 2x plus 3. So my two scenarios require me to have the 17 and the negative 17, but on either side of the 2x plus 3, so that the 2x plus 3 solution is actually sandwiched in between the two 17 and negative 17 scenarios. So I'll go ahead and solve. Subtract 3, subtract 3. 2x is less than 14, divide by 2. X is less than 7. All right, subtract 3, subtract 3. Negative 20 is less than 2x, divide by 2. Negative 10 is less than x. So right now, I've got that x is smaller than 7 and x is bigger than negative 10. So when I go to my solution, I'm going to put those two numbers on here. Negative 10 is smaller, so it goes on the left. This is a less than, so it's an open circle as opposed to less than or equal to. And then look at what it says. X is smaller than 7, so it's going to shade to my left. And x, it says negative 10 is less than x. Or if I flip it around, x is greater than negative 10. So that means I'm going to shade this way. And that's what I'm talking about, that they overlap, that it's bigger than negative 10 and smaller than 7. So my solution is all contained between the two. Sometimes you'll see people break into their two scenarios and they'll write it something like this. Negative 17 is less than 2x plus 3 is less than positive 17. And then they just solve it like that. You could do the 2 like I have here, or you can write it all together like we do here. But negative 10 and 7, or x is less than 7, x is greater than negative 10. And this graph are your full solutions.